Hey guys, so today we're going to talk about exponential growth and decay and finding the rate or the common ratio, the multiplier that tells us how we're getting from one number to the next in our pattern here, when in an exponential pattern to be specific. So we're asking ourselves essentially, how do we get from 1 to 3 using multiplication? So that looks like times 3. That one's pretty basic. 3 to 9 times 3. But if you're ever unsure, you can always divide by the previous number. So if we take 3 and divide by 1, we get 3. If we take 9 and divide by the previous number, 3, we also get 3. 27 divided by the previous number 9 equals 3. 81 divided by 27 equals 3. So the multiplier here is 3. Looking to the right, this one's a little less obvious maybe. What am I multiplying 125 by to make it 25? So we can use our previous strategy, 25 divided by 125. When we simplify this simplifies to 1/5. This is getting smaller each time. Makes sense that our multiplier would be a fraction because this is decay. And decay is going to be a fraction. Over here in this first example, this was growth because the pattern is getting larger over time. So checking the next one, 5 divided by 25 is also 1/5. 1 divided by 5 is 1/5. So our multiplier here is 1/5, and that's representing decay. So what is exponential growth? It's a b value that is greater than 1, and this is going to represent a pattern that is growing over time. Exponential decay is a b value that's less than 1, but greater than 0, and this is going to show a pattern that is shrinking over time or getting smaller. If we're given a table to find the b value, again, we're looking, what could we multiply by? So what number would we multiply by to make 12? Again, this is getting smaller over time, so we're looking for a fraction or a value between 0 and 1. You might feel like you're dividing here. If you feel like you're dividing, we're going to have a fraction. The other strategy is to take this number, divide by the number before it. 12 divided by 24 equals 1/2. In other words, 24 times 1/2 should equal 12, which it does. Again, we take the next one, 6 divided by 12, which simplifies to 1/2. So our multiplier or our b value here is going to be 1/2. That's how we get from one number to the next in the pattern. Let's look at this next one. 2 multiplied by what equals 6? Well, that's going to be times 3. We can also take the previous strategy, 6 divided by 2, and that equals 3. Now let's check the next one, 18 divided by 6, and that equals 3. 54 divided by 18, I bet equals 3. So the multiplier here is 3. Remember, this is decay if it's a fraction, and if it's a whole number, growth. This pattern gets bigger over time, whereas the first table got smaller over time. Again, this next pattern is getting smaller over time. This looks again to be 1/2, and we could check by doing 2 divided by 4, which equals 1/2. 1 divided by 2, which equals 1/2. 1 divided by 1/2, which also equals 1/2. So again, our multiplier is 1/2, and this is decay, getting smaller over time. Here, we could ask ourselves, what would we multiply by? You might feel more comfortable looking down here to the whole number portion of the pattern. We could again use the previous strategy, 2 divided by 1 equals 2. Up here, we could do 1/4 divided by 1/8. When we're using fractions, we invert and multiply. So this would be 1/4 times 8 over 1, which would equal 8 over 4, which is 2. So again, this multiplier is 2, and this would be growth, getting bigger over time. If you're using a graph to determine this, you can look at the shape of the graph and reading left to right, determine if we're increasing or decreasing over time. As I read this first example from left to right, my y values are increasing. If they are increasing, this is growth. Then to determine the multiplier, we can look for the pattern. To go from 0, 1 to 1, 2, those 2 points there. So the 2 points I just saw were, 0, 1 and 1, 2. How would I get from 1 to 2? Multiply by 2. Let's check that that pattern continues. The next point is 2, 4. To get from 2 to 4, we would multiply by 2. Again, we could take 4 divided by 2, which gives us our answer of 2, again representing growth. Looking at the next pattern, we can also see that this is growth. We have a different starting value over here. We don't start at 1 anymore, but we are still growing over time as we read from left to right. We are increasing, so this is growth. And then we're looking for the multiplier. How are we growing? Our first point is 0, 3. Our next point is 1, 12. This looks like a multiplier of 4, or 12 divided by 3, which is 4. Given that those are the only 2 points we can very clearly see, we are going with a multiplier of 4, which again represents growth. Down here, we're looking as we read from left to right, and now our y values are decreasing over time. As we read from left to right, the y values are going down. I can see a nice clean point here of, so that means decay, right? So decreasing is going to be paired with the word decay. And we start at 0, 9, and the next clear point I can see is 1, 3. I'm asking myself, how do I get from 9 to 3 using multiplication, or 3 divided by 9, which simplifies to 1/3. Again, we expect to see a multiplier of a value less than 1, but greater than 0, because this is decay. So this value matches what we would expect. This next graph is also going to be decreasing as we read from left to right, which goes with decay for exponential functions. The first point I see here is 0, 2. If we look up, negative 1 appears to be at 4. So that would actually be the next point here. Negative 1 would be 4. And then 1, 1. So this appears to be a multiplier of 1/2. I would multiply 4 by 1/2 to get to 2, or we could divide 2 by 4, which simplifies to 1/2. We could check that with our next point, 1 divided by 2, which also equals 1/2. So our multiplier here is 1/2, which again matches what we expect for decay. In a word problem, we're asking ourselves, first of all, are we growth? Is it going to be a growth or decay word problem? And then this little bucket is going to represent what we're going to keep. Starting with 100%, we're either going to add to the bucket or take away from the bucket. So if the bucket represents 100%, we can either add to our bucket, overflowing, getting additional, or we can take from our bucket to represent decay, losing value. So in this first example, you are given a new job, your salary is $50,000 a year, and your guaranteed increase is 3%. So if we start with our bucket at 100%, are we going to be adding to our bucket or taking away? Well, this is an increase. An increase means we're going to add to our bucket. What are we adding? 3%. 3%, of course, is going to go into the bucket then because we're adding 3%. What is our total now in our bucket? 103%. But of course, when we plug that into an equation to use as a multiplier, we're going to turn that into a decimal instead of using a percent. Remember, percent means out of 100. So if we take 103 and divide by 100, our multiplier is going to be 1.03. Again, we started with 100% of our income. We're going to add to that every year. What are we going to add? 3%. That gives us 103%, which turned into a multiplier of 1.03 to get rid of that percent symbol there. Next example over here, we're going to invest $10,000 and we're going to get an interest rate of 5%. Interest rate means that you're going to earn money on the money you have invested. So this is again going to be growth. When we have growth, we start with 100% and then we add on to that. we're adding 5%, which is going to give us 105%. 105% total in our bucket. Again, that's a percentage. Percent means out of 100, so to turn that into a decimal, we'll divide by 100, which gives us 1.05 as our multiplier. Again, a value greater than 1, both of these so far have represented growth. If you get an iPhone, it's going to lose approximately 25% of its value every year. That's a bummer. That sounds like loss or decay. If we're doing decay, we're starting with 100%, but now we're losing value. What are we losing? 25%. When we subtract, that gives us 75% left. Again, we need to turn this percentage into a decimal that we can actually use as a multiplier. So we take 75 and divide by 100. That gives us 0.75 as our multiplier. Notice this is a value less than 1, which matches what we expected, decay. Again, another way to think about this actually is to ask yourself, what do you get to keep? If you lose 25%, you get to keep 75%. The half-life of a bacteria sample is 2.4 minutes. Well, half-life means it's going to cut in half each time. So 1/2 is going to be our multiplier here. This one's a little weird to think about in the bucket, but basically we're taking 1/2 of every sample. So we're going to get smaller each time. That's going to be decay. What are we decaying by? 1/2. $20,000 is invested at an interest rate of 1.7. Well, it sounds like we're starting with $20,000. That's 100% of our investment. And we're going to add 1.7% every year. That's going to give us 101.7% growth. So this is growth. We're going to add to our wealth here. That's what we want our money to do. Again, to turn this into a multiplier, we have to divide by 100. That gives us 1.017 as our multiplier, a value greater than 1. It's not drastically greater than 1, but your money is still going to grow over time. Bacteria culture doubles every 40 minutes. Doubles means times 2. So the multiplier in this case is times 2. Every 40 minutes, this bacteria will double. That means the multiplier is definitely growth, and the growth rate is times 2. So the multiplier is times 2.